So let me introduce myself. I am Dr. G.P. Rao, working as a senior scientist in Jan Clausen Division of Rubber Institute of India. This institute is working under the Rubber Board, Government of India. And in this institute, Rubber Board, we have three centers. One is research R&D institution, that is the Rubber Institute of India. And Rubber Training Institute, that is meant for this training of the farmers and all students and all these things. And then we are also having Rubber Production Department, which deals with the production of rubber planting materials and distribution to the farmers and all these things. So coming to the this one from my institute, in this presentation I will show some of my rubber aspects, research my aspects also in this presentation was included. So you can through this presentation you can understand all these aspects. So with this I will proceed to my presentation. So my topic of the presentation is on potentiality of genetic resources and their conservation for sustainable rural development. So I am actually working on this conservation and all these aspects for the past 30 years. So you can understand one by one all these aspects. In a nutshell, I will explain. So we can very well, it is very known aspect that this conservation of biodiversity. So UN I declared this decade of 2021, 11 to 20 as a decade of biodiversity. So this is a very important aspect of our globally. It is very important aspect of our, all human beings. So it is very clear. So historically, the human society depends on biodiversity for food and livelihood. So this diversity world, access to adequate food and primarily concern of the most of the people on the set. This makes agriculture one of the largest and most significant industries in the world. Agriculture productivity is important not only for a country's balanced trade and the security and health of the population. So agriculture shows its variations from early evolutionary slash and burn to the settled territory and values cultivation. So modern times, unwise human interferences, nature has created many problems. Ecosystem sustainability is at the threat. So this paradoxical high variation in agriculture practices and cropping systems called for identifying research strategies for support in agriculture systems. So with this global change in population growth, climate change, and overconsumption of ecosystem services, we need further integration of poverty alleviation and biodiversity conservation. A total of 616 protected biospheres natural reserves are spread across 120 countries as per the UNESCO. So current status, around 70 to 80 million species are present on this earth. Among these, flowering plants, a total of 55 families contribute to the domesticated food plant species. A total of 2,297 species of cultivated plants belongs to the 167 families. So India, one of the 12 mega biodiversity countries of the world, and it has two hotspot areas pointing to the biodiversity. So these are the global biodiversity hotspots. The Indian subcontinent has 1.6 million plant and animal species. India hosts 49,000 plant species and 33% of endemic and 75,000 animal species. Indian region, important center for the origin of diversity of 356 crops under cultivation. Further, 160 domesticated crop species and 20 species of their wild forms are close to rich diversity in Indian gene center. Out of 15,000 species flowering plants, 2,560 are tree species. More than 20 agricultural crop plant species have been domesticated. So genetic resources and their conservation. Germplasm is a total sum of genes present in a species. It consists of 5 types of materials, that is land races, absolute varieties, varieties in cultivation, breeding lines, and wild forms and wild varieties. So biodiversity exists in the form of organizations in different types, that is genetic level, species level, and ecosystem level. So germplasm preservation is accomplished through gene banks and preservation of natural habitats. The local original crop species in a basic plant breeding is one of the locations is very important related to species, new genes, and endless research per gene. So the concept of search per gene in new germplasm was proposed by Gautam. The cultivation of plants were not distributed uniformly throughout the world. So Russian scientist N.I. Vavilov developed the theory of centers of cultivated species. In 1926, Vavilov proposed the croplands evolved from the species in areas showing greater diversity in terms of primary centers of origin. Croplands were not domesticated randomly, but they are regions where domestication started. Crop diversity crop moved from one place to the other due to human activities. Some of the crop species have shown considerable diversity, such as known as secondary centers of diversity. So knowledge of the origin of croplands is important in order to avoid genetic erosion. And information on genetic diversity of plants and is useful for plant breeding and crop reserve programs. These are the Vavilov centers of diversity. So collection is very important of genetic diversity is very important among crops such as the rice and wheat is two more important crops feeding humanity. Genetic erosion of wild and progenitors was, as I told earlier, it is alarming. So there is an urgent need. So because these wild plants are replaced by the traditional new varieties of crops, so there is urgent need for arresting the situation. So further, there is a need for collection of relevant germplasm materials for center of origin and diversity, followed by conservation, characterization, domestication, and use. So this population, world population is by 2025, it is expected to be around 2.15 billion. So similarly, in India also, by 30, it is 1.5 billion. So there is a scope for increasing arable land. There is no scope for increasing the arable land, and further humans need due to more food and food. So there is existing genetic base is also further broadening is required because this is narrow genetic base. So it need more wild germplasm requirement. So objective of genetic conservation, mainly there are three aspects. So expanding the basic of a germplasm materials required for the expanding biotic and abiotic stresses. So conserving for changing consumer preferences, and then yield increase for meeting the world population. The objectives and main time scale in conservation of genetic resources. So before 1800 BC, hunter-gatherers, that is for next to the one-day meal. Now after 1850, that primitive traditional peasant farmers, that is for next crop for 1 year. So plant breeders 1850 after onwards, plant breeders started for developing varieties for next 10 years. So after 2016 onwards, genetic conservation is their main as objective is the gene-based conservation for 100 plus years. So this is a full spectrum of germplasm in a crop species. These are genetic reservoirs, areas of diversity, areas of cultivation, breeding for resistant R&D centers. These are the full spectrum of genetic resources. So frontier areas, priority areas of this conservation was undertaken by various centers. Like for the past 6 decades, efforts have been made by the international organizations like FAO, IPPGR, CIMMET, etc. like this. So they have taken a lot of efforts with conservation evaluation. And then in India, the NBPGR is a nodal center, and they have made agri-horticulture crops conservation and collection, all these aspects in situ conservation. So mainly in cereals, legumes, oil seeds, and food and industry crops, and particularly industry crops such as the rubber and other crops. Rubber Institute of India and IRDB, they are doing all these aspects. The main collections are priority areas or species are very important in rice, wheat, sorghum, minor millets, and regions of diversity areas. So diversification of genetic base. So the limitation in traditional cultivation areas are leading to the further expansion of non-traditional areas. In these marginal areas, crops were confronted by various biotic and abiotic stresses, leading to lower production. The present yield levels and more cultivated crops are plateau and due to narrow genetic base. So there is a existing, therefore, the existing genetic base has to be broadened to increase the productivity levels and incorporation of desirable genes. The only way out is to diversify the genetic base of the cultivars, which in turn required genetic analysis of existing genetic resources. So genetic basis and main adaptability and stability is very important in any crop species for their yield. The analysis of parents, the wide adaptability, high yielding varieties indicated the pools of diverse gene blocks are very different from land races and distribution, and their wide adaptability is very important. So, for example, we have rice variety IR60, IR36, wheat, chenab and chennai, pearl millet, sorghum, chickpea, all these things having wide diversity. So, like this analysis of high yielding varieties, divergent gene blocks are very important. This is present in IR36, number of land races 14, and IR60, IR44 in rice variety, land races are there, C306 land races. And then in wheat, Chenab 70, Shaloi, these are the land races in wheat, pearl millets, BK 560, all these things are available in this one. And like sorghum and the chickpea, and then genetic base and stability is very important. These are varietal development purpose needed. They are having very low number of land races, present cultivars having low number of land races. So there is in-depth study is required to incorporate the more number of land races. For example, we have noted that Golin noted a small set of semi-dwarf genes were entered into plant design for the development of varieties. So there is a indicated narrowness of the original gene base. So now there is a broader base of genetic base is very important in the 21st century to cope up the demands of yield and other aspects. The stability of cytoplasm constituents are very important. The analysis of the mitochondrial DNA is very important for salt and drought tolerance. The genetic characteristics association with the adaptation of land races is very important. The diversity analysis is generally natural mutations and very high under natural specific ecological conditions. So genetic diversity in natural population with specific adaptation is very important. So such analysis is required in rice, millet, sorghum, chickpea, etc. in different countries. So dwarfing genes also very important, as we know that the rice, division and Norin 10 are very useful genes in wheat and rice and wheat. So is it important the genes for dry matter production and utilization of genes in dwarfing genes, and a wide range of adaptability started research in All India Coordinate Programs in ICR in India. Only small portion of the, as I told, collections have been actually entered in the present day advanced future lines. So future jump in yield required greater diversification of genetic base. There is an urgent need to evaluate the world collections. Further, there example for a pearl millet example, harvest index widening the variations in the local conditions. Utilization of genetic alternative sources of dwarfing genes are very important. The transfer of these genes also very important. Adaptive mechanisms are to study, and there is a new tools for now. These frontier science like GIS and computer technologies are very useful. The identification of biodiversity hotspots and the collection of identification of genotypes relevant to the research development. So molecular techniques like RFPD, RFLP, SSR are very precisely useful for characterization of plant genetic resources. Now the biotechnology aspects such as genome, gene sequencing, like CRISPR-Cas technology, etc., are very simple and powerful tools to editing genes and provide tools for transfer of specific genes to the new varieties. Similarly, protoplast fusion also very important. The sequencing of technology is useful for dwarfing genes and example of a distinguishing common and contrast features and incorporating multiple sources in the physiological aspects to the new varieties. So genetic analysis of gene marker level is important. The inhibitor genes and similar evaluation 6P, PGNP, PGNP, groundnut is very important. Drought tolerant strategies are very important, and since the strategy specific, seed specific uh, uh, physiological aspects are affecting the growth and yield in semi-arid tropical conditions. So this is the scheme for effective utilization of germplasm, collection of exotic germplasm from different centers, and a collection of exotic germplasm and used in different centers from National Bureau of Plant Genetic Research in India, like this, and then collection and evaluation centers. So after this data evaluation and centers to the main data processing centers, it will go, and from main maintenance centers, germplasm maintenance centers, it will go. From there, it will go to the catalog and distribution to the breeders and researchers. From there, it will be used in the plant breeding programs. These are the different aspects of germplasm conservation evaluation. And then utilization aspect. So there are germplasm utilization very important. So I have narrated here different traits for a crop improvement used in different crop species. So for example, plant height in wheat, dwarfing genes, and rice and the dwarfing genes. The lodging resistance in wheat and rice, these are the genes. So photothermal sensitivity in rice and wheat, earliness is very important. These are the different genes available. They are under use. Dormancy in moong and barley, etc. These are the genes, and cytoplasmic sterility. These are the different genes under use, and quality traits in rice. These are the different genes. In sunflower, it is 0.5 is resistant source genotype. In sugarcane, these are the sources. And cotton, this is hot CPM. And then potato storage is important. These are the having very good quality traits, these genotypes. And then plant response to fertilizer. These genotypes are very responsive and resistant to diseases, wheat rust, and then rice, bacterial blight, and tobacco mosaic virus. And then resistant to rice pests. These are the pest resistant genotypes, groundnut resistant genotypes, abiotic stress in drought and salinity resistant genotypes in sugarcane. And come to the abiotic stress in wheat, drought resistant genotype, and this is the drought resistant in gram. And then rice, these are the drought and acidity resistant genotypes. These are the salinity tolerant genotypes. And then these are the alkaline soil tolerant genotypes in the wheat. And heterosis means the high yielding improvement. These are the heterosis phenomena. So these are the genotypes used for hybrid development and heterosis phenomena purpose. The drought tolerant genotype. The other specific traits, traits are important for different crops and different locations. These are common being. These are the upright determined crop available here, and then Kesari pulses seeds. This is identification elimination of toxic gene, toxic substance. This variety, capsicum, is available in Boot Jaloka. This is available in Assam. This is having high pungent and chili, high pungent variety. This is used in very defense and all of the activities they are using. So in India, these NDPs are having holding the germplasm exceptions in different crop species. This is as on 2019. These are the different number of genotypes conserved. Totally conserved 4,100, 1,900 genotypes are conserved in National Gene Bank in India. And then similarly, there are tropical fruits, temperate fruits, all are conserved in vitro and in vitro gene banks, 217. So coming to the rubber, so as I'm working in rubber and it's a very useful crop, so I want to add a little bit about this rubber. I think it will be very useful to all of us developing countries. So para rubber is a eco-friendly crop. It is a native of Amazon basis. So 99% of the global requirement of rubber was meant for the developing countries. So this is useful in 50,000 products. Most recent domestic crop of the world. So globally, rubber cultivated this many hectares and production is this much, 12,000 products. Asia accounts for 93% of the production. India is coming the fifth, and in the production it is sixth position. Yield average is 1,629 kg per hectare. It provides a livelihood to the over 1.39 million in India, and not only in India, all the rubber growing majority of the Asian countries, and it is majority growers are small holders, that is below 5 acres they are cultivating. It is very useful, and useful is the rural development, and foreign exchange in India getting 155.3 billions, and this supports an industry of annual turnover of 30,000 crores in India. So these are the natural rubber immature and mature plantation for the general features. This is how this rubber is tapping. You will get in cup. So these are the collected in the rubber and made rubber sheets. So this is how rubber is after tapping. The tapping is the rubber bark, and the tapping is from this latex veins. It will come out from this latex vessels. So historically, the rubber was collected into 1800 by Henry Wickham from the Amazon basin. That is very few seedlings. They are collected and distributed to Sri Lanka, Singapore through this fund. And there are story about 22 survival seedlings only. All developments came in Southeast Asian countries. Rubber was originally introduced in India in 1902, and the yield levels during that time were only 300 kg. Now they have developed clones and varieties that are giving yield 3,000 to 4,000 yield kg per hectare. So due to this narrow genetic base, it has 22 seedlings. So the plantations, Southeast Asian countries, genetic base is very narrow. So that this is the original, this is the rubber distribution in the genus in Amazon. These are the that is distribution different locations, actually around India and different locations in rubber. So this rubber growing countries in the world, though it is a native of Brazil, these are the countries are growing in rubber. So rubber prefers equal climate, and then this rainfall, all these things required high rainfall. And then in India, it takes 7 years to reach yield level. In other countries, suitable area countries, it is 5 to 6 years is optimum required for growth and development. So this is the rubber sheets getting out of rubber, and these are the rubber growing areas in India. This is the traditional area, Kerala and Tamil Nadu, this traditional area. Now the rubber is due to shortage of land resources and the high demand, rubber is growing all our Indian countries. This is Maharashtra, the Andhra Pradesh, Orissa, West Bengal, this is Northeast India. This is the second most rubber growing parts of India, but this is affected by the stress conditions. So genetic variability is a prerequisite for any crop, and particularly in rubber also it is required. So to broaden the genetic base, so rubber growing countries found one union that is known as International Rubber Development Board. They have conducted one expedition during 1981 and collected more than 64,000 seedlings and seeds and orchid materials. And then actually now I want to say that this Amazon area, this Mato Grosso photo was taken. So every day there is a 12 football grounds of area was removed from the forest. So this one photograph taken during long back. So only one tree in the Metagrosso area. Like this, a lot of deforestation is going on. So this during 81 expedition, they have conducted this Amazon basin in 3 areas. From these 3 provenances, these states were collected this Janpal materials. These are the 3 areas, Janpal material, and distributed to the member countries. India is one of the member countries, and we have received Janpal. So this is the condition. In India, we have 4,540 Janpal materials are conserved in Indian center, and then we have domesticated 183 domesticated Janpal materials, and we have 5 species also. In India, we after conservation, we are conserving in nurseries, and then after that we are characterizing, evaluating, and screening of Janpal. There is drought and cold resources. So this is the conservatory, how the Janpal materials are conserved in the field in vitro and the field gene banks. So after this one, we are characterizing germplasm using morphological traits for developed for these genes. So this is the descriptors developed for this rubber characterization. These are the variability of flower, leaf, branch, plants, fruit variations. So far we have done for the past 30 years. We have characterized the morphologically and molecular characterizations we have done. The wide variability was observed for various traits, morphological traits, bark traits, and superior genotypes were identified for various yield and growth traits. Yield we have identified more than 55 genotypes. These are the Metagrosso provenance is showing a very high yield and very vigorous genotypes among the 3 provenances. So this is how we do large-scale evaluation of preliminary evaluation. So we have identified genotypes for Phytophthora, Oidium, and Cornospora diseases. So this is the how this field tolerance, and then screening for drought tolerance. We have studied this evaluation in Maharashtra, and these are drought prone area. Chhattisgarh also drought prone area near Orissa, and then cold studies we have done in Nagarkatta. This is sub-Himalayan West Bengal area. It's very important area, sub-Himalayan areas. There we have identified cold tolerant clones. So this is the drought areas, how drought affected plants, the survival plants. This is the good germplasm. And this is how this germplasm material showing drought tolerance traits. So this is the what I told Nagarkatta. This is the sub-Himalayan foothills of sub-Himalayan area. This is just below Bhutan, adjacent to the Bhutan and West Bengal. Here, this during winter season, early of my research study. So few genotypes only screening per time survived few genotypes. And all plants are affected. So these selected genotypes only we have selected and further evaluation purpose. So we are also doing the screening for timber traits. And this is how this rubber timber was used for furniture and other making purposes. So utilization also we are using these selections for different purpose, utilization breeding purpose.
Sir, please conclude. You have
okay. So coming, these are this one. This is the you see how breeding from a low yielding to now it is reached the high yielding. So this is one rubber variety. We are getting a lot of income from this. So conclusion, these are while the selections are we have identified selections for different crops. So this is the different crops, the different varieties identified: drought, cold, yielding purpose, all these things. So effective Janpal collection is very important for yield improvement in India and throughout our country. So these are the conventional use of the Janpal material. So this is our initiation. So thank you very much. So thank you very much, and I will close down my presentation, please. Yeah, thank you. So this is overall my presentation is over.